Hello everyone, welcome back once again to my channel. So today we're learning how to create dynamic loan amortization schedule in Excel. So by the end of the lesson, you should be able to create a dynamic loan amortization schedule which you are able to perform the dynamic financial analysis and financial modeling as well. So we'll learn how to create periodic payment, and then from there we also perform what if analysis on the years. What if the year changes to this? What should be the periodic payment? And then also look at the increase in the interest rate on the loan amount. What if the interest rate increases? What should be our periodic payment based on the number of years? So these are the things that we are going to cover in the next video. So let's get started. Okay, so as you can see here, I have some basic information here. The loan amount is 100 US dollars. Interest rate is 5 is 10%. Then the number of years 20. So I've let me restart this. I'm going to remove this. So now we need the years column, the opening balance column, interest rates, total payment, which include both interest and then the principal amount. Then we also get the closing balance as well. From there, we also perform sensitivity analysis on the years, on the periodic payment as well. So assuming the interest rate increases, what should be the periodic payment based on the selected year? So these are the few things I will be covering in this video. So let's get started. So let's predefine the year. So we can start by making here one. So one here. Then let's increase it by one for each of the year. Let's drag this up to 20 years. Good. So we have this. Then for the opening balance, we are saying that it should be what equal to this. Then from there we can also calculate our interest payment. So interest payment, we use some function in Excel which is IPMT. So start typing IPMT, that's the periodic interest payment. So these have four arguments. So the first one is the interest rate. So the system will be making reference to this cell. So you have to anchor it both the column and then the row. Then the next argument is the total number of years. Again, we'll be making reference to this throughout the number of payments. So let's also anchor this both the column and then the row as well. Then the next argument is so sorry, the first argument should have been the each year that you're making the payment. So we will not anchor that. Then the next argument is the total number of years. So let's anchor this since we're making reference to this. But the year one, this argument here, the B9 will keep changing because year two, it will be updated by itself. Then the last argument will be the loan amount. The loan amount. Okay, so again, that one too, we have to what? Anchor it. So we are going to anchor both the column and then the row as well. So now we are good to go. Let's hit enter. So this is the interest rate for year one. So when you multiply 10% by 100,000, give you 10,000 US dollars. Then again, we also have to calculate the total payment, which will include the interest and then the principal amount. So let's also make it is equal to start typing PMT. So now we also have to define the various arguments. So the first one is the interest rate. Again, This also have to be anchored, both the column and then the row should be anchored as well. Then put comma. The next argument is the total number of years. Again, we have to anchor this as well. And then the next or the last argument is the present value of the loan, which is the current loan value, that amount that we are taking. So I'm going to anchor this as well. So I'm okay. I can hit enter. So this is the periodic payment, which include interest and then the principal amount. Okay, so since we know the total payment and then the interest component of that, we can extract the principal amount. So you can make is equal to this minus this that will give out this. So when you add this plus this, should give you the total interest payment or the total payment as well. Then with the closing balance should be equal to the opening balance plus the interest rate less the total payment. But remember, the interest is showing negative, so you have to make it negative that to turn to positive. So we can make here the opening balance minus the negative interest, which will make it now positive. Then we can now add this. Since we are less, so when you add it to the negative, automatically replace the positive figure. Then once you are okay, we click OK. Good. So now we are saying that when we are taking a loan of this amount for 20 years, the first year interest will be this. This is the total payment that we are required to make at the end of the first year. Out of that, this is the principal component of that payment. And this will be the closing balance. So now we can put equal to here and then drag this. So meaning that so we can what? Fill this column down to the last year. So you can see that here is 0. So at the moment, that's why you can see here showing 0. Then for the interest rate too, we can also drag it as well. So here too, there's nothing there as well. So the interest rate keep reducing. Then again, we can also drag this column as well up to the last year. So you can see that for the total payment, it keep repeating the same amount every year. So you'll be paying this amount every year for the next 20 years. As you are paying, your interest rate or the interest payment should be reducing. Okay. So I'm dragging this as well. So now we can see here. So that now, as you can see, by the end of the 20th year, the loan amount becomes 0. So meaning you will have finished paying that loan amount. Okay, good. So now let's now assume that the year, why if we are giving the loan amount for just 10 years, what should be the periodic payment? So for example, meaning we can change it to 10 years and see the result. So you can see that this doesn't look good in your table. So I think we can do something about it. So see, this doesn't look good. So so you can see that even here, this is not changing. So we want to define that depending on the year, the year should also increase by that margin. Then whenever there's no the period does not cover this, or the loan amount does not cover this period, then here should be empty. So let's start with the number of years. So you can say if the previous year is less than the total years, comma, then the system should add the previous year plus 1. Otherwise, it should give us empty year because that year doesn't exist. Okay. So let's anchor this since we will always be making reference to this column. So let's anchor this as well. Good. So let's drag this. So by the time we have gotten to the 5th year, from the 6th year should be empty. So as you can see here. So the moment we change the year here, you can see that it will be increasing. Good. Increasing. Here is increasing. Good. But all these places we have to do something about it. So here too, we can also model here as well that if again this is less or equal to, because every year you have to pay interest. So either it's less, you pay interest, whether it's equal to, you pay interest. But when the year is greater, then you're not paying interest for that period. So it's equal to this date here. So comma. So again, we have to anchor this as well. So let's anchor here. Good. So we are saying that if year one is less or equal to the total years that the loan will be paid off, then you should calculate the interest for that year. Otherwise, meaning if it's false or the year here is greater than the total number of years, then there shouldn't be any interest for that year. So it should give us an empty cell. So again, I'm going to drag this. Good. So you can see here, it has obeyed because look at here, the year is what? 7 years. So the last interest will be on the 7th year. For any number here, where the system recognizes that is greater than this, so they will not calculate any interest. And again, let's apply the same principle here. If the year under review is less or equal to the total number of years, comma, again, let's also anchor this because we'll be making reference to this throughout. Then we are saying that if the year under review is less or equal to, so it means that if you are in the last year, you must pay the periodic payment. If the year is less than the total year, you will still make payment. Good. So once it's less than, then you have to what? System have to perform this function. Otherwise, the moment the year that we are under review is more than the total number of years that we have agreed, then it should give us empty SL, close the bracket, hit enter. So you can accept the argument then. So let's look at it again. So if the year here is what less or equal to this, so let's make it comma. So let's log this reference here, log this. One is not equal, it was greater, let's make it empty. Okay, good. So let me drag this down as well. You can see something happen. So you can see here, still we are in the 7th year. So from 8, we don't expect to see anything. Okay. Then let's also look at here. Here too is showing that there is no value to be computed because these cells are empty. So you can also use a simple function here. If error, so it's giving us error. If you subtract this from this and give it error, then make it empty. Okay. Again, let's drag that to the last year as well. Great. Then here too, we can also define something as well, the closing balance. That if, so let's do that. So we put a cursor here. If, so again here for the closing balance, it will only be calculated when the year under review is what? Less than the total number of years. So what it means is that if the year is equal or more, there's no way we should have any closing balance. Okay, so let's also pick here if this is less than the total number of years here. So let's also anchor this as well. So we anchor this. Good. So now we are saying if the year under review is less than the total number of years, so 1 is less than what? 7. It means that we have to have a what? Closing balance for the remaining year 2 to the seventh year. Good. Otherwise, which means if the year is greater or equal, then we shouldn't have any balance outstanding at the end of that year. Enter. So let's also drag that to the last value. Good. So now as you can see, let's change here to 10. Great. So you can see here we are in the 10th year. So the 10th year we have reached paying the loan. So now there will not be any balance. Let's change here to 20 years. Excellent. So you can see here the 20th year. So year 1. So you can see we are down payment. So there's nothing for us to pay again. Let's change this one to year 5 and see. So you see here you are able to create dynamic loan amortization schedule where you should be able to perform what if analysis. So here you can say what if the year changes to 10, what should I be the periodic payment? So you can see. So that you are paying this amount. If the year increases to 15, your periodic payments will reduce each year. So this will help you to be able to what? Bargain how long you should take the loan as well. Okay. So now we can do something. We can't keep changing this all the time. Then we should be able to create a form control where you should be able to select that year, then it should flow into this. So in order to do that, let's just create some numbering here. 1. So let's increase it to 20. Okay, so to 20. All right, so let me remove the last 3. Okay, so now on your ribbon here, scroll down to the developer tab. From there, look for insert. From insert, we have all the various form controls here. Click on this form control. You can see that the cursor is showing plus. Put it at anywhere. So you can see here, you resize this to any sizable column that you want. Cool. Then we can, once it's showing this in a design mode, right click it, scroll down to form control. Here, so form control give you, so you have the input range. The input range is this series of numbers that we have created. Hit enter. Then a link. Whenever we select this range, where should it be linked to or reflected to? So we have to link to this number of years. Enter. Hit enter. Good. So now we'll be able to select this column, this years here. Good. And again, we can also change this and label this as number of years. Good. And again, we can also resize this well. And then let's also resize this well. Okay, so let's bold this. Okay, so now as you can see here, so whenever we want to perform sensitivity analysis, so assuming the interest rate remain the same, what if we bargain for 20 years from here that are updated? What if we are bargaining to 16 years or 5 years? What should be the result on each of these? So you see, so this is how you're able to set up the sensitivity analysis on a loan amortization. So here you have given management the ability to be able to choose any year, and then you'll be able to see the result of their periodic payments. Okay. So since this is the focus, let's try and then format this using the any color scale, and we can just use only one color. Okay. So whenever it changes, the class will also reduces. Good. Excellent. So this is how you create it. So let's good. So now you have the dynamic amortization schedule. Now, so you can see that always we will not able to compare the total payment anytime the year increases. The total payment also changes. So now let's also create what if analysis on the total payment, assuming the interest rate increases. So this is the current interest rate, assuming the rate is 15, where we are going for the loan term is for 20 years. So since it is not par, let's hide this so we can make it white to go off. Okay. So now, so this is the next thing here. We are going to perform sensitivity analysis, sensitivity analysis on the interest rates for periodic payment. So our focus is to be able to consider why if the interest rate increases to 15 and we are paying the loan for 20 years, what should be the periodic payments? Why if the interest rate increases to 20? What, so our focus here is to what? We are going to compare the periodic payments under each of the different uh, analysis. So the first thing here is so here you have to create a row. So the row represent here the interest, as you can see from the top. So you can just input the interest and then increase it by any number of your choice. Then here to you create a series of numbers up to the 20th year, which is the same as the one that we have from the original loan amortization schedule. Then again, now let's now do something here. So the first, since we are going to perform the sensitivity analysis for the change in the interest rate for the periodic payments, then we have to know our current periodic payment, which is this one here. We want it to be here as well. So you can just make equal to any of these amounts here. So as you can see, because this is what we want to be, we want the system to recognize that whatever we are doing here is that we are making reference to the what periodic payment. Okay, so once you have this a periodic payment over here, you can highlight all the areas that you want to perform the sensitivity analysis on. So it's up to there. Good. So once you highlight all this column, including the current periodic payment based on the current interest rate for 20 years, as you can see from the original table here. So after you have highlighted all this, you click on the ribbon here, the data. From there you scroll on your right, you can see here what if analysis. Click on that. You can see there are three items here. Let's move to the data table. So let's click on the data table. So here it require two main arguments. The first one is a row input cell. So this represent for on our side is the what? These are the row which represent the interest. So we have to make reference to the original interest rate, which is this. Then the next argument is the column input cell, which is this. This is a column. So now the original year is for how many years? 20 years. Once you're okay with that, let's click OK. Excellent. So look at what happened. Let's hide this. Since we have this already, let's hide this. All right. So let's also format this as well. So let's highlight. this and then format it. So you go to your formatting, color scale. So let's choose the one that will be good. I think this is good. So now, as you can see here, we are saying that, so at the moment, this is our, if we are taking a loan for 20 years, this is our current what? Repayment year on year, assuming the interest rate remain the same. Now we are, so when you come here, 10 against 20, so you can see here, 11,746 US dollars, which is the pure repayment here. Now look at it here, and also assuming the rate remain the same, but the period has been reduced. Look at here. So this, so assuming it's for 1 year, we'll have paid this interest. 2 years for 10 years. This will be the periodic payment. Assuming 10 years and it's for 3 years, this will be a periodic payment for 3 years. Then as you can see here, so see, if the rate changes to 15%, and we are still taking the loan for what? 20 years. So let's zoom into 20. So you see, your periodic payment will be what? 15,976. Then in that order. So you can see that the deep green represent the lower payment, and as it continues from going right, the green decreases. They can also see here that those in deep red here or wine here represent what? The amount that that increases the amount that you'll be paying more. So from this range you'll be paying more. Then as you continue from this angle too, it's also what? Lower than the other amount if you're to be taking just 1 year. So as you can see here, so now when you perform this, you can now run this and see. So your loan all updated. So you can see here you are taking the loan for how many years? For 15 years. This will be your periodic payment year on year. And then when also the rate is 10%. So let's also pick that, move it to 15. So you can see here 13,147, 13,147. So being able to develop this amortization schedule, and then you're able to perform sensitivity analysis, it will help you to be able to what? Management to be able to make their decision. Okay, so assuming the interest rate is 15, and we are taking a loan for just 20 years, our yearly payment will be what? 15,976. So maybe we can also reduce it to 5 years and see what happen, and make here 10, make here 15, make here 20, 25 here, 30, 35, and the 40. So as you can see again, assuming we have been able to bargain a lower interest rate against the original amount, and we are paying a loan for 20 years, our periodic payment will be what? Just 8,000 against what? 11,000 based on the what? 10%. So this is how we create dynamic amortization schedule. Thank you for watching. Kindly subscribe to enjoy more dynamic financial modelings ahead. Thank you very much. See you again in the next video. Practice to so that I can be able to perform this in Excel. Bye.